we will learn about distributed embedded architectures from module 6 of embedded system. What is a distributed system? It's a system whose components are located on different networked computers which communicate and coordinate their action by passing messages to one another. What are the main components in a distributed embedded system? It consists of several processing elements, either it's a microprocessor, microcontroller, or ASI, application specific ICs, are connected by a network and that allows them to communicate. So using via network they are communicating each other. The application is distributed over these Ps and some of the work is done at each node in the network. What are the reasons to build a network based embedded system? First one is the processing tasks are physically distributed in an embedded system. Distributed embedded system. So it may be necessary to put some of the computing power near where the events occur. For an example, consider automobile. കൺസിഡർ ചെയ്യുകയാണെങ്കിൽ ഒരു എൻജിൻ കൺട്രോൾ എന്ന് പറയുന്നത് ഷോർട്ട് ടൈം ഡിലേ റിക്കവർ ചെയ്യുന്ന ഒരു പ്രോസസ്സാണ്. അപ്പോൾ അങ്ങനെയുള്ള ടാസ്ക് ആ എൻജിൻ്റെ നിയറിൽ തന്നെ അതിൻ്റെ റിലേറ്റഡ് ആയിട്ടുള്ള ടാസ്കുകളെല്ലാം ആ എൻജിൻ്റെ അടുത്ത് തന്നെ കൊടുക്കുകയാണെങ്കിൽ ഇതായിരിക്കും നമ്മുടെ ടൈം ഡിലേ എന്ന് വി ക്യാൻ റെഡ്യൂസ് ദ ടൈം ഡിലേ. സോ നമുക്ക് കമ്പ്യൂട്ടിംഗ് പവർ എവിടെയാണോ ഇവൻ്റ് ഒക്കർ ചെയ്യുന്നത് അവിടെയാണ് നമ്മൾ കമ്പ്യൂട്ടിംഗ് പവർ പ്രൊവൈഡ് ചെയ്യുക. ദെൻ സെക്കൻഡ് വൺ ഈസ് ഡാറ്റ റിഡക്ഷൻ. Second one is data reduction. It may be possible to perform some initial signal processing on captured data to reduce its volume. For example, detecting a certain type of event in a sampled data stream. സോ നമുക്ക് ക്യാപ്ചർ ചെയ്യുന്ന ഡാറ്റയിൽ സം ഇനീഷ്യൽ പ്രോസസ്സിങ് അല്ല സിഗ്നൽ പ്രോസസ്സിങ് ആപ്ലിക്കേഷൻ പെർഫോം ചെയ്ത് കഴിഞ്ഞാൽ വി വിൽ ഗെറ്റ് എ റെഡ്യൂസ്ഡ് ഡാറ്റ. സോ നമുക്ക് പ്രോസസ്സ് ചെയ്യാൻ ഇറ്റ് വിൽ ബി ഈസി. Then third one is modularity. When a large system is assembled out of existing components, then those components may use a network port as an interface that does not interfere with the internal operation of the components. Then fourth point is it's also used to easier to debug. The one part of the network can be used to probe component in another part of the networks. Then last point is network are used to build fault tolerance into the system. So these are the reason to build a network based embedded system. So നമുക്ക് ഈസിയർ ആണ് ഡീബഗ് ചെയ്യാൻ. ഒരു പാർട്ടിൽ എന്തെങ്കിലും എറർ ഉണ്ടെങ്കിൽ നമുക്ക് എന്താ നെക്സ്റ്റ് പാർട്ട് യൂസ് ചെയ്ത് വി ക്യാൻ കറക്റ്റ് ദാറ്റ്. So main points are tasks are physically distributed, data reduction, modularity, easier to debug and build a fault tolerance. Then what are the main components of a distributed embedded architecture? The basic unit of a distributed embedded architecture are processing element PE and the network. Here this is the diagram of a example of a distributed embedded system. Here there are 5 P's processing elements are there. One is instruction set processors such as CPU processor, then DSP and microcontroller, and non-programmable units such as AICs. AIC means application specific ICs and IO devices. Here IO devices are sensors and actuators, and these different PCs are communicate each other via this network. Here we are using bus network. So the connection between the P's provided by the network is known as communication link, and the system of P's and network forms the hardware platform. In that hardware platform the applications are run. Then the distributed embedded system does not have a memory on this bus and do not fetch instruction over the networks. Then why distributed? Distributed systems are necessary because the device that the P's communicate with are physically separated. So already told that the applications P is processing devices are physically separated and they are communicate each other by using a network. So if we want to communicate physically separated devices, we require a distributed system. If the deadline for processing the data are short, it may be more cost effective to put the piece where the data are located. സോ നമ്മൾ പ്രോസസ്സിങ് ഡേറ്റേൻ്റെ ഡെഡ്ലൈൻ എന്ന് പറയുന്നത് വളരെ ഷോർട്ടാണെങ്കിൽ നമുക്ക് ഏറ്റവും കോസ്റ്റ് എഫക്റ്റീവായ മെത്തേഡ് എന്ന് പറയുന്നത് എവിടെയാണോ ആ ഡാറ്റ പ്രോസസ്സ് ചെയ്യുന്ന ആ ലൊക്കേഷനിൽ തന്നെ, ഡാറ്റ എടുക്കുന്ന ലൊക്കേഷനിൽ തന്നെ ഉള്ള പീസിൽ അത് ലോഡ് ചെയ്യുകയാണെങ്കിൽ ഇറ്റ് വാസ് ബി ഈസി. ദെൻ next is the important advantage of distributed system with several CPUs is one part of the system can be used to help diagnose the problem in another part. നമ്മൾ ഒരുപാട് CPUs ഡിസ്ട്രിബ്യൂട്ടർ യൂസ് ചെയ്യുകയാണെങ്കിൽ ഒരു പാർട്ട് എന്തെങ്കിലും ഫെയിലിയർ ഒക്കർ ചെയ്യുകയാണെങ്കിൽ we can use another part to diagnose that. And if you have several CPUs in the system, you can use one to generate the input for another and to watch the output. അപ്പോൾ നമുക്ക് ഒരുപാട് CPUs യൂസ് ചെയ്യുന്നുണ്ടെങ്കിൽ കുറച്ച് CPUs നമ്മൾ ഇൻപുട്ട് ജനറേറ്റ് ചെയ്യാൻ യൂസ് ചെയ്യാം, അനദർ CPUs എന്ന് പറഞ്ഞാൽ ഔട്ട്പുട്ടിനെ വ്യൂ ചെയ്യാൻ യൂസ് ചെയ്യാം. ദെൻ നെക്സ്റ്റ് വൺ ഈസ് നെറ്റ്വർക്ക് അബ്സ്ട്രാക്ഷൻ. Already നമ്മൾ പറഞ്ഞു the speeds are connected by a networks. So to describe the networks, we are using an international standard organization developed Open System Interconnection Model, OSI models, that consist of 7 layers. This provide a standard way to classify the network components and its operations. There are 7 layers are the already studied in computer networks. The first one is physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. The main functions of physical layer is the property of the interface between the system. It include the physical connection and the electrical properties and the basic function of the electrical and physical components and the basic procedure for exchanging the bits. The next layer is data link layer. Layer is error detection and control across a single link. It's mainly used for reliable data transport. And third layer is network layer. Its main function is end-to-end data transmission service. Here data is considered as a packet. And next layer, transport layer, it consists of connectionless and connection oriented services. And for next layer, session layer. Section layer provides a mechanism for controlling the interaction of end user service across a network, such as data grouping, checkpointing, and dialog control. And the presentation layer defines the data exchange formats and provide transformation utility to the application program. Then last layer, 7th layer, is application layer, which provides the application interface between the network and the end user program. These are the main function of the 7 layer in the OSI model. And next one is hardware and software architecture. To understand the distributed embedded system, here we are using different types of interconnection networks. First one is point-to-point networks. Point-to-point networks or link establish a connection between exactly 2 pieces. If we want to connect between 2 pieces, we are using point-to-point link connection. This is an example of a signal processing system built from point-to-point links. Here we are using 2 digital filters, F1 and F2, and here input device and output device. First, the input device sampled the input signal and is passed to the filter F1, digital filter F1. And here this is the first point-to-point link. Then this output of the first filter is passed to the F2, second filter, using the another point-to-point link. Here we are using a third point-to-point link that passes the output of the F2 filter to the output device. So we can there are using a either full duplex point to point connection or a half duplex point to point connection. If a full duplex point to point connection means is mainly used for simultaneous communication in both direction between the two pieces. If we only requires the communication between in a only single one way direction, then we are using half duplex. So simultaneous communication in both direction between the two pieces, we use a full duplex. In one way data communication, we are using half duplex. Then another network is bus network. It allows multiple devices to connect to each, and there are 4 pieces are there, and these pieces are connected by a bus network. And here bus network, the messages are passed as a packet. The packet containing the header, address, data and ECC. The packet contains the address for the destination and the data to be delivered, and it can include error detection and correction information such as parity, and it's also include signal to other pieces that are in the buses in use that containing the information in the header. So other ഡിവൈസിനെ ഇൻഫോം ചെയ്യണമെങ്കിൽ we are using the header, and address is the destination address of the processing element, and data payload data is specified here, and error correction and detection is here, such as parity. Then another one is the bus system must be arbitrated to control simultaneous access. So we need to access simultaneous pieces. So to control that simultaneous access, we are using some arbitration schemes. So mainly there are 2 types of bus arbitration schemes are there. One is fixed and another one is fair. The fixed priority arbitration always gives priority to competing device in the same way. That means if a higher priority and a lower priority device both want to transmit the data at the same time, then the lower priority device will not be able to transmit anything until the higher priority device has sent all its data packets. So only fixed priority arbitration, higher priority device can only transmit the data. After that only lower priority device can transmit data. Second arbitration type is fair arbitration. In this schemes, there is no device is starved. That means round robin arbitration is used here. So round robin means rotate the top priority among the P's. So according to the priority, it will all P's will be executed in a certain time interval. So there is no starvation here. Then another network is crossbar networks. Here crossbar is allows all combination of input output connection to be made. Here IN1 can communicate to out4, IN2 can communicate to out2, IN3 can communicate to out2, and IN4 can communicate to out1, or any combination is allowed here. So here if a IN1 input line 1 is want to communicate with or send a data to out2, then the cross point, this is known as the cross point, that is the connection to the switch that connects the input to the output, that is known as cross point, and the cross point between IN1 and out2 will be connected here, and it will pass the messages through this line. So that's why any input device or P's can be communicated to other device. So next one is multi-stage networks. Multi-stage network have immediate routing nodes to guide the data. Here we are using several stages of switching elements. Here if we want to, this input P2 is want to communicate with output point 3, then here is the switch element, that switch transfer the data through this and here switch to the here. So using switching element we can switch to any output device. And one of the properties is often used blocking. What is blocking means? There are some combination of source and destination for which message cannot be delivered simultaneously. ഇപ്പം ബസ്സിൻ്റെ കേസിലാണെങ്കിൽ നമുക്ക് ബസ്സിൽ ഒന്നിലധികം ഡിവൈസിന് സൈമിൾട്ടേനിയസ്ലി ആയിട്ട് ഡാറ്റ ട്രാൻസ്ഫർ ചെയ്യാൻ പറ്റില്ല. സോ സം ഡിവൈസ് ബ്ലോക്ക് ചെയ്യും. സോ ക്രോസ് ബാറിൻ്റെ കേസിലാണെങ്കിൽ നോൺ ബ്ലോക്കിംഗ് ആണ്. അതുപോലെ തന്നെ ഇവിടെയും നമുക്ക് കുറേയെല്ലാം കേസിൽ നോൺ ബ്ലോക്കിംഗ് ആണ്. ആൻഡ് ഇറ്റ് ഈസ് ഓഫൺ സ്മോളർ ദാൻ ക്രോസ് ബാർ. ദെൻ another is message passing. Message distributed embedded system do not have shared memory, so they must communicate by passing messages. So the messages as the natural communication unit. So here a message must be broken into packets to send on the network. So here this is the message, sent message. We are passing the parameter address of the destination and the data. So it will be passed. If the message size is larger, then it will be divided into packets. So these packets are put into a loop, and length of the message അത്രയാണോ അത്രയും ടൈം ദിസ് ലൂപ്പ് വിൽ ബി ഐറ്ററേറ്റഡ്. സോ I is equal to 0 up to message length, then that message or packet will be sent to the destination address and the corresponding data, and the data is broken into the at the source side and it will be reassembled at the destination side. Then another method is data push programming. Is making things happen in network based on data transfers. Mainly this data push programming is used for periodic data. Periodic data means if the data will always be used at regular intervals, and we can reduce the data traffic on the network by automatically sending it when it is needed. So for example, here is a automobile which is distributed sensors are here and actuators are there, and these distributors and actuators talk to the central controller when it requires the send a controller to request it. If we need to send a data, it send a request to the central controller in usual case. In the data push network, here we know that the sensors are generally need to sample data periodically. So in such a system, we are the sensors to transmit their data automatically. So data push network architecture, the sensors are used to send data periodically automatically without requesting to the controller. സോ ഓരോ പീരിയോഡ് വെച്ചിട്ട് നമ്മൾ ഒരു റെഗുലർ ഇൻ്റർവെൽസ് വെച്ചിട്ട് സെൻസേഴ്സ് ഡാറ്റ സെൻഡ് ചെയ്ത് ഓട്ടോമാറ്റിക്കലി ഇറ്റ് വിൽ സെൻഡ് ടു ദി കറസ്പോണ്ടിങ് പാർട്സ്. സോ ദാറ്റ് ഈസ് ഡാറ്റ പുഷ് നെറ്റ്വർക്ക്. These are the different networks used in the embedded system. Today's section will be end here.